Imagine a stealth teammate that never blinks, never needs oxygen, and reacts in milliseconds to threats you haven't even seen yet. That is the promise behind Lockheed Martin's Skunk unveiling of Vectis, an AI wingman built to fly with frontline fighters like the F-35. Skunk describes Vectis as a survivable, 5th-gen ready wingman with open systems by design. Company claim: not a render, a roadmap. Vectis is positioned to team natively with 5th-generation fighters and is being advanced on a near-term first flight target. Company claim. Here's why that matters. In the next 3 minutes, I'll show the mission where Vectis completely changes the outcome, and how that cascades into training, doctrine, and budgets. Subscribe if you want first-to-publish breakdowns of the biggest AI and defense moves, then settle in as we decode how Vectis could change the way air forces fight. 1. The vault door opens. Why Vectis matters before it even flies. Skunk has a track record of turning impossible into operational. The U-2 gave decision-makers eyes they had never had. The SR-71 outran problems that grounded lesser jets. The F-117 made stealth a practical verb. That lineage matters because it reveals a culture. Small, empowered teams, ruthless focus on mission effects, and aversion to tech theater. When this group shows a new aircraft concept, the message is not nice rendering. It is, we intend to field capability you can actually fight with. Modern air combat has shifted from raw kinematics to information advantage. 5th-gen aircraft like the F-35 aggregate radar, infrared, and passive electronic sensing into a fused picture and share it across encrypted links so a formation behaves like a single organism. 2 constraints persist. First, human cognition is finite. Even elite pilots can be saturated by simultaneous sensor feeds, data link updates, and pop-up threats. Second, budgets limit how many exquisite, crude platforms a nation can buy and sustain at high readiness. Quick take: pilots don't need more screens, they need fewer, better decisions. That is where the collaborative combat aircraft idea, the AI Wingman, enters. Team a piloted fighter with 1 or more unmanned partners that extend sensors, add weapons, soak risk, and create combat mass without putting a human in every cockpit. The catch? Make it work inside truly contested airspace. You need survivability so the aircraft persists under modern integrated air defenses. You need autonomy so the pilot is not babysitting a remote toy. You need deep integration so the wingman speaks the same data dialects, rides the same networks, and fits the same playbook as the crewed jet. Operators view survivability first, everything else second. Vectis signals that trifecta is maturing. The pitch stresses best-in-class survivability, company claim. Open systems aligned with government reference architectures and teaming with frontline 5th-gen fighters. For operators already flying F-35, that combination is powerful. A wingman that thinks in the same conceptual language, plugs into existing mission planning, and evolves at the speed of software. In theaters defined by distance and dense air defenses, that is not a luxury. It is the difference between showing up and shaping outcomes. Where this places Vectis in the race right now? Squarely in the survivable wingman lane, competing to penetrate contested airspace while attritable swarms handle mass and confusion at the edges. 2. Inside the shadow. How Vectis stacks stealth, autonomy, and adaptability. Vectis stands out because it stacks stealth, autonomy, and adaptability as one integrated system, not separate checkboxes. Start with survivability. Low observability is not paint. It is geometry, materials, seams, apertures, and emissions. Discipline tuned across the frequency bands and aspects that matter. Inlets, doors, panel edges, edge treatments, thermal management. Each choice trades performance against signature. If the platform cannot persist where modern radars hunt, everything else, sensors, weapons, autonomy, is academic. One risk: survivability decays without rapid software and EW updates. That is why a secure, repeatable update pipeline is as critical as the airframe. Layered on that foundation is autonomy with the human on the loop. The commander defines intent and constraints. Escort this package, screen on this bearing. Prioritize electronic protection over kinetic engagement. Avoid these threat fans. Disengage if risk exceeds threshold X. Within those guardrails, the autonomy stack manages formation geometry, sensor allocation, route refinement, and defensive reactions at machine speed. The pilot is not puppeteering. The pilot is directing a teammate that understands goals, proposes options, and executes Vault. Sensor fusion is the next pillar. Every sensor can be fooled in isolation. Radar spoofing, IR clutter, deceptive emissions. But together they triangulate truth. Vectis fuses radar, IR, electronic support, and offboard feeds into a single probabilistic picture that reduces ambiguity and pushes the formation's perception bubble forward. Because it is unmanned and stealthy, it can occupy geometry too risky for a crewed jet. Then push that fused awareness back to the team. Quick take. Push your eyes forward, keep your crew safe. Electronic warfare turns perception into control. A modular, software-defined EW suite lets Vectis blind or confuse threat radars, protect friends, and carve corridors through dense defenses. Software-defined matters because threat libraries evolve. Update jamming techniques and deception waveforms via secure pipelines, not airframe surgery. Weapons flexibility closes the loop. An internal bay implies defensive air-to-air options and precision air-to-surface effects, plus space for stand-in jammers or advanced decoys. Over time, expect tighter collaboration between platform and munitions, weapons that share intent, exchange updates in flight, and coordinate timing with the Wingman. 3 lanes, 3 trade-offs: attritable drones, cheapest, low survivability, mass; Vectis class, higher cost, high survivability, contested roles; crewed 5th gen, highest cost, highest flexibility, limited mass. Race context reminder: the winner is not the flashiest silhouette. It is the ecosystem that updates fastest and integrates cleanest across this 3-lane mix. Finally, adaptability. Open systems aligned with government reference architectures allow third-party sensors, autonomy behaviors, and mission apps to integrate quickly. Digital engineering and model-based systems shorten design loops, expose integration issues earlier, and turn flight tests into confirmation rather than discovery. Result: a platform that accrues capability, not a snapshot that ages the day it is revealed. 3. From briefing room to battle space, 5 missions where Vectis bends the curve. Now, where Vectis bends the curve, on mission. SEAD Corridor. A 4-ship of F-35’s holds at the edge of a radar belt while 2 Vectis wingmen slip forward under tight emissions control. They passively map emitters, build a fused threat picture, and propose a corridor where jamming will rupture the tracking gate. The flight lead authorizes a tailored electronic warfare profile. Vectis maneuvers to optimal geometry, blinds the radar at the decisive moment, and the F-35’s release standoff munitions from survivable lanes. If a pop-up site lights, Vectis reacts in milliseconds with a decoy or defensive shot, then repositions to continue the screen. That was SEAD. Now Maritime Strike. A surface action group weaves beneath layered defenses. The crewed formation stays outside the thickest rings. Vectis goes stand-in, building a high-confidence target track with passive sensors and selective emissions. The human lead green lights the salvo. Weapons arc in from safe lanes while Vectis quietly monitors effects and cues retargeting if defenders shift. Result: contested precision without rolling dice on aircrew survivability. High-value asset transit. Tankers are oxygen. Vectis protects the lungs. Stealth pickets patrol likely approaches, listening for fighter radars and cruise missile seekers. If an intercept forms, Vectis sanitizes the path early, cues escorts with time to spare, and fractures the intercept chain with deception waveforms before the tanker is threatened. Distributed operations. When fixed bases are under pressure, dispersal is survival. Vectis can operate from smaller sites with modular payloads. One sortie, it extends a resilient comms mesh across islands and sea. Next, it escorts a strike package with an electronic attack kit that punches holes in a radar screen. After that, it totes precision munitions for a time-sensitive target. The airframe persists, the mission kit rotates. Coalition training. Pilots practice intent-based tasking of multiple wingmen while displays make autonomy legible at a glance. What Vectis is doing, why, and what options are next. Debriefs include machine-readable logs that reveal the AI's decision branches. Allies validate secure data exchange, common ROE adherence, and cross-fleet teaming. The Force learns faster together than any unit can alone, and speed of learning becomes its own deterrent. Viewer outcome hook. If you build AI products, this is the template for software-defined autonomy at the edge. If you track defense equities, watch the software cadence. Value will migrate there? 4. Whispered briefs and big bets. What operators, analysts, and policymakers are watching. Operators care about friction. If Vectis plugs into the F-35 Enterprise, mission planning, secure links, tape loads, debrief tools, adoption accelerates because crews are not relearning their world. The best feature is the one that disappears into muscle memory. An AI wingman becomes indispensable the moment pilots feel bandwidth return to their minds in the busiest parts of a fight. Analysts point to ecosystems beating standalones. In a software-defined battle space, the best airplane is the one that integrates, updates, and scales fastest. Open systems are no longer a checkbox, they are the procurement baseline. Customers want to pace threats with software, not wait for hardware refresh cycles. They want sovereign options, national sensors, local EW techniques, preferred autonomy behaviors, without surrendering interface control. If Vectis truly aligns with government reference architectures, capability can compound across partners instead of calcifying inside a vendor silo. Comparative frame, attritable mass for saturation, survivable wingman for penetration, crewed 5th gen for flexibility and command. Budget reality. Leadership will fund mixes that deliver the most effects per day at acceptable risk, not the cheapest sticker or the flashiest demo. Human factors remain critical. The interface must let crews express intent simply, confirm authority cleanly, and understand autonomy at a glance. Explainability is not academic. It turns trust into tempo. An AI suggestion that shows confidence, alternatives, and rationale speeds approval and keeps the pilot focused on the parts of war only humans do well. Ambiguity, ethics, trade-offs, leadership. Vectis advances if it proves faster, safer integration with 5th-gen tactics than rivals can offer. Measurable outcome? Spare bandwidth in the hardest minutes. When pilots report mental margin where they previously had none, doctrine and budgets follow. For you, if you benchmark Edge AI, Vectis is the practical case study for human on the loop done at speed. If you're an investor, track update velocity, not just airframe counts. 5. Tomorrow's playbook. 10 predictions for how Vectis could rewire airpower. Here is tomorrow's playbook in 10 moves. 1. A staircase of flight milestones, ground runs, taxi, first flight for handling qualities, envelope expansion, avionics maturation, then sensor checks, robust data link demos with crewed jets, electronic warfare profiles on controlled ranges. Finally, weapons carriage and employment under scripted ROE. Each step converts slides into sorties and trims integration risk. 2. A mission app ecosystem. Open architecture invites certified third parties to deliver autonomy behaviors, sensor processors, and EW techniques as software. Squadrons receive new capability on operational timelines, not calendar politics. 3. Teaming doctrine hardens. Playbooks codify roles like stealth screen, stand-in jammer, decoy shepherd, armed scout, and comms node. Simulators let a few pilots orchestrate several wingmen until complex choreography looks simple. 4. Mixed fleet economics. Nations buy a survivable core for contested penetration and a broad attritable layer for mass and deception. Procurement shifts from how many airframes to how many effects per day at acceptable risk. 5. Coalition interoperability proofs. Multinational exercises verify jam-resistant data exchange, common ROE enforcement by autonomy stacks, and secure cross-fleet teaming. Export pathways likely become tiered. Some payloads or behaviors remain domestic, others are releasable with safeguards. 6. Human-machine interface breakthroughs. Intent-based tasking, confirmed to commit prompts, and debriefs that show why the AI acted, not just what it did, reduce cognitive load. Trust becomes measurable when pilots report spare bandwidth in the hardest minutes. 7. Policy frameworks mature. Standards settle around testing autonomous behaviors, logging, auditability, cybersecurity, and human authorization. Programs that embody those standards move fast, those that do not stall. 8. Weapon platform collaboration tightens. Stand-in jammers, smart decoys, and networked munitions share intent with Vectis, adjusting routes, seekers, and timing as the fight evolves. The line between aircraft and payload blurs into a cooperating web. 9. Distributed ops become default. Dispersed basing, agile turnarounds, and modular kits let small footprints generate outsized effects. Vectis becomes connective tissue that keeps a force lethal when runways, fuel lines, and comms are under stress. 10. The culture flips. The moment a pilot says, "I had bandwidth left when it got hardest," the AI wingman graduates from experiment to expectation. Why this mix wins in 2028 versus rivals: the force that updates fastest, integrates cleanest, and measures human mental margin will own the tempo. Vectis is not a gadget. It is a thesis about where airpower is going. Stealth as the canvas, software as the paint, autonomy as the brush, guided by human hands. Pair a pilot's creativity with machine speed precision, and a formation begins to think as one. Which mix wins in 2028? 60% attritable and 40% survivable wingman, or the reverse, and why? Subscribe, drop your take, and let's build the smartest channel on the future of AI and airpower.